Hello, welcome to another video. Today we are solving this very interesting puzzle and we will learn a lot of cool science things throughout the video. And there is bonus at the end of the video, so make sure you watch that one too. See you. Okay, so as you can see, this puzzle says that when it is complete, it will be 73 centimeters times 48 centimeters. When this puzzle is complete, it will be made by 1000 pieces and they are almost all of them the same size. So let us go ahead and measure one, then see how long is it, which happen to be around 1.9 centimeters on the length and on the width. So it is based on a small square that is approximately 1.9 centimeters times 1.9 centimeters. So yeah, and we saw that when it is complete, it will make a large rectangle that is formed by 1000 pieces. So the area will be 1000, and this will be the width and this will be the length. So that means since you know that at the end of the puzzle it will form a rectangle, we can go ahead and then attempt to find how many pieces will be on the width and on the length. And by doing that, we will have to find two integers which multiply to make 1000. Then we list all the possible factors of 1000 and then see which ones can work. And as you can see, this will be a very ridiculous rectangle, same as all this, because the width will be very, very small. So it will be like a very narrow thing. These two last cases seem to make a reasonable rectangle, especially the last one of 25 and 40. Yeah, so if the case was 20 and 50, that would be 50 here, 50 on the length, and 20 on the width. And also, as you can see, you can eliminate one of this by checking on the ratio of this image. So let us go ahead and then measure how long, what is the ratio of the length to width here. So that should be the same ratio of these things, either this or this. We will see which one to pick. Okay, so let's go ahead and measure this. 13.3 centimeters, 20.1 centimeters, yeah. Okay, so let's find out what the ratio will be. That is 20.1 divided by 13.3, which gives us 1.5, around 1.5. So the ratio should be around 1.5. No matter how much you squeeze or enlarge a rectangle, the ratio of the length to width will still remain the same. And of course, 2050 will not give us the ratio of 1.5, but maybe 2540 will. If we do 40 divided by 25, we get, of course, around 1.5. So yeah, of course we made some errors, so this is the right ratio to go with. So indeed we need 25 here and we need 40 on this side. Yeah, I start by finding the corner pieces. There are pieces with two straight edges, one for each corner for the four corners, and then after getting them, I find the pieces with one straight edge that will make the perimeter. After getting the perimeter, then I fill in the rest of the pieces. After having the perimeter, then I go ahead and then divide all the rest of the pieces according to their colors to make it easy for me to build things. Then I start by building some obvious figures like the windmill in this case. just try to find what is the ratio of magnification from this small picture to the completed one. So we are just going to measure anywhere on the figure. So this one is like 10.4. This length is 10.4, and this one is something like 2.95. Yeah, so we will divide them and see. So if we divide them, we get 3.52. So that's the ratio of magnification. I'm going to introduce this device I'm using, which is called a magnifying glass, and this one bends light. So it focuses light at one point. As you can see, it is transparent, but it's a lens, so it bends light and focuses it at one particular point. I can bend the light from the far window to this white paper. You can see the white sky on the bottom, and you can see the blue carpet on top. So the image is in this case inverted. So let us see how this device exactly works. Let us analyze the lens. So the lens has a focal length, you can see it at f on both sides, and it is the intersection of two spheres, but in this case we use two circles. You can see the object from distance u from the lens, and the image which is formed from distance v from the lens. And we need the magnification to be 3.52 for us to see the original image as large as the completed image. And so we have to find the focal length of the lens because it is very important, and we can do that by having an object which is at infinity. So in this case we will have 1 over infinity, which is 0. Then we can find the distance from the lens to the image, and then we call that the focal length, of course. Yeah, so I happen to have an object at infinity, which is of course the sun. So there you go, the sun, so bright. So let's use it and see if we can measure the focal length using it. Yeah, so I'm going to focus the sun on this shoe, and the place where it will burn will be the place where the focal length lies. So let's go ahead and find it. This here is the sharpest image right here. As you can see, there is some smoke. It has indeed started to burn. So let's measure how long is this distance. Yeah, this is the place where it was burning. Let me measure it and see how long is it. The focal length was around 10 centimeters. So, and you know the magnification is v over u, and you need it to be 3.52. So we can express v in terms of u and then plug it in our formula, and we know f, we know also v in terms of u, then we can find u, and we computed u to be 7.2 centimeters from the lens. So we need to place the object from that distance. Now we conclude that if I place this image at 7.2 centimeters from this lens, then I'm guaranteed to have something as big as this one. So let's try to see if that works indeed. I'm not sure if this is very obvious. Yeah, I guess this is about the required centimeters, right? Now we know how to make our magnifying glass give us the required magnification. So the first thing to check when putting in a piece somewhere is of course the color, but also the how does it fill in, because not all the pieces are exactly the same size. So sometimes you try to fill in the piece which fits color, but it doesn't fit. That's the first sign that that piece should not be there. Yeah, as you can see, around this windmill wings, everything is built. Around these leaves, everything is also built, and around the edges also is built. I hope there are not that many mistakes, but here it looks like there's some mistakes because they don't look like they fit quite well. And here also they look like it's loose. Yeah, all these places around.
And then I try to squeeze.
As you can see here, it goes. But here I was stuck. I have so many options.
From them,
Which one to take, which one to not take. Yeah, so I'm currently using this approach of building the edges, and then when I'm done, I build also another layer around them till I squeeze in the whole thing, and then at the end I will be done. Let me show you what I'm saying. So apparently I'm almost done. Yeah, you can see it here. I'm almost done. But problem is there are many flaws on this thing. For example, some things don't fit. This one looks too dark. This one too dark. This one also too dark. So that means they should belong somewhere else. Also, some things like here, like this one is a bit dark. That means it should be somewhere. And some things here also, they look suspicious, like this one and this. So yeah, this is how it's going. Finally, after so many weeks of hard work, I have finally arranged this whole thing. You can see, look, piece by piece, 1,000 pieces from the first piece to the last one. Look. So let's take one last selfie with it. Let me show you something about these corner pieces, and this one is on the top left corner, top right, bottom left, bottom right, right? So if you want to connect them together, these ones will connect, right? But these ones vertically, they won't connect, right? Because there is like it looks like I miss one piece here to connect them, right? And here the same thing goes here, but horizontally they will connect, right? And the reason is because the length, that means the horizontal length is even, but the vertical length is odd. Let me show you what I mean. Like if I count all these ones, I will get an odd answer. But if I count them horizontally, the answer will be even, of course. So there are 25 pieces here and 40 here. I want to show you what motion with respect to the frame of reference mean. So this big board, I'm going to move it, and it will look like this small board is the one which is moving. As you can see, apparently it's like the small guy is moving, but he is not. I'm telling you, the big one is indeed moving. Let us see a more mathematical way of computing lengths. As we saw it, this original box specifies it. So we have 73 centimeters, which is made by 40 pieces. So each piece should be 73 divided by 40, and here horizontally, vertically, each piece we have 25 pieces, right? So we must have 48 centimeters divided by 25, which gives so the area of this very big picture is 73 times 48, and the area of only one piece, if you assume that all the pieces are equal in area, then the area of one piece will be this one divided by 1000. And of course the side of one piece, if we assume that it is based on a small square, then the side will be the square root of its area, and that happens to be 1.87. Which happens to be the average of what we have got earlier. So if you do the average of this, you get around 1.87. And this is not too bad, because if you remember earlier, we have calculated using a ruler, and we got one side to be 1.9. Of course, we have made some errors, so it was around indeed 1.9 centimeters.